everyone. So I want to talk about physical changes, chemical changes, physical properties, and chemical properties because you have a test soon and we want to make sure that we really understand this. So one thing when we're talking about a change, okay, so if this was a Venn diagram kind of in the middle, something that they both have in common is that a change refers to something being different. Okay, so something is different and there's a before the change happens and now there's something afterwards. Okay, and it's different from what it was before. So when we're looking at a physical change is when something is different but the identity of the substance stays the same. Okay, so for example, if I have water and it is currently a liquid, and you should know that L in parentheses like that in an equation means liquid from unit 1. Okay, so if we have water and we see that it changes into, let's say we put it in the freezer and it changes into a solid. There is something different here. It goes from a liquid to a solid. However, the identity of water, H2O, that remains the same. So because H2O is the same on both sides, that means its identity has remained the same. It is not changing the chemical bonds. Okay, that's the important part there. The bonds are remaining the same. Okay, you still have two hydrogens connected to one oxygen. That bond is still there. Okay, a physical change is only going to break the attractive forces between them. And so when we look at a chemical change, okay, this is where the identity of our substance is changed. Okay, and so this means that bonds are broken. Okay, so for example, if we look at water again, and we have water as, I don't know, let's say it's a gas this time. Water can decompose or undergo a decomposition reaction to break apart into hydrogen gas and oxygen gas. Now, this would happen in a balanced ratio, so it would have a 2 there and a 2 there to be a balanced equation. But what we can see is that the identity of water is no longer the same. Hydrogen and oxygen are split. So H2O compared to hydrogen and oxygen separate are different. Let's talk about some examples of each of these. So if we're looking at examples of a physical change, so we talked about freezing, melting, paper, paper being cut, right? If you cut a piece of paper, the form and the shape have changed, but it's still paper. If we're looking at examples of chemical changes, anything that's burning, baking, reacting, okay, any of our 5 types of reactions, so synthesis, decomposition, single replacement, double replacement, combustion, all of those things are examples of chemical changes. Rusting, so iron rusting is a chemical change because it literally goes from iron, which is Fe, it reacts with oxygen in the air to form Fe2O5. And so Fe2O5 is that reddish brown rust that we see, but we can see that the chemical formula actually changes. So that is a chemical change. Now, so remember, with changes, it's something is different from before and after, and whether or not its identity has changed will determine if it was physical or chemical. So now I want to talk about physical and chemical properties. And so similar to before, what is a property, right? Because these are different. So a change was when something is different from before and after. A property is a description of a characteristic. Okay, a description of a characteristic, if I can spell this correctly. I'm totally butchering that spelling, but you understand what I'm saying. So it's a description of a characteristic. Specifically, when we're looking at a chemical property, this is going to describe how it interacts with something else. For example, sodium reacts with water, or is reactive with water is probably a better way to phrase it. It's describing how it is interacting. It's reactive. So that is an example of that. Now with physical property, this is just when it's being described, it results in no change. Okay, so when I look at something, for example, the word change, I might say that it is black, right? That's the color, and it doesn't automatically change what it is. Or I could maybe measure the length of that word, and that would be a physical property. If I have a tennis ball, right, I could calculate the density of it. I could weigh it and get its mass. That would be an example of a physical property. But then with chemical properties, it's talking about its ability to interact with things, and so we would maybe be talking about pH. Is it an acid or a base? We'd be talking about flammability. Okay, is it flammable? Will it catch on fire? Is it reactive? Okay, reactivity. Does it react or does it not react? And the reason why these are important is because if I want to know if something is flammable, I have to attempt to catch it on fire. And if it does, it will change what it is. So it's usually observed in the middle of a chemical change. And so this is very important to keep in mind, these differences here. So please review these and look over them. One thing that I also want to mention, this is a little bit of a sidebar, is don't forget about your conversions and being able to convert. That was on your last quiz. So some key conversions is that 1,000 milliliters is equal to 1 liter, and 1,000 grams is equal to 1 kilogram. And so this is important because when we're doing density calculations, and I know we weren't really talking about that now, but when we're doing density calculations, our units need to be in grams and milliliters for our mass and volume respectively. So for example, let's say if I have a question, just how many grams are in 0.27 kilograms, right? So if I have that, I want to change kilograms into grams. And so this equality here can be turned into a fraction. So I could write it one of two ways. I could write 1 kilogram over 1,000 grams, or I could write 1,000 grams in the numerator and 1 kilogram in the denominator. And so what this allows me to do is to change my 0.27 kilograms into grams by multiplying by this fraction. And so because I start with kilograms at the top, I'm going to also put kilograms on the bottom. And so I'll choose the fraction where it says 1 kilogram on the bottom is equal to 1,000 grams. And so when I multiply across 0.27 times 1,000, I'm going to get 270 grams because my kilograms are going to cancel out with each other. And so what this is saying is it's creating a new equality, that 0.27 kilograms is equal to 270 grams. And so just keep in mind this skill for your test, and good luck.